Hi, this is a presentation about Trend's IP tool, a tool within SET you will use to set up IQ system devices on an Ethernet network. When you complete this presentation, you'll be able to launch IP tool, explain how IP tool communicates with IQ controllers, discover IQ system Ethernet devices on a network segment, configure the Ethernet parameters of an IQ3 controller, and add a remote device to a remote Trend devices table. Before I dive into using IP tool, I want to review briefly information you should already know about Ethernet networks. It's important to understand how Ethernet networks work, so here's a brief refresher. Trend's IQ3 controller line uses industry-standard Ethernet physical and data link layers and TCP/IP communication protocols. IQ3 controllers operate over the Ethernet network using standard addressing, IP address, MAC, and UDP port. Yet, Trend retained backward compatibility with its proprietary network protocol by overlaying the legacy addressing model on top of Ethernet and TCP/IP. Trend uses a single method of communicating between Trend IQ system controllers, even those on different network types using different protocols. This allows intercontroller communications between Trend controllers regardless of the network type. The physical network that supports the IQ3 installation is fairly flexible. There are three components to be aware of: cables, switches, and routers. A standard Ethernet cable is an unshielded twisted pair, UTP, with a maximum length of 328 feet. That's 100 meters. Because it is unshielded, be careful of installing the cable next to sources of electrical radiation. There are several types of 10-base T-cable manufactured, the primary differences between them being the number of twists per foot and communication bandwidth each supports. Each manufacturer indicates a standard CAT rating for each cable. For example, Cat3, 16 MHz and 16 megabits per second. Cat5e, 100 MHz, 1000 megabits per second. Cat6, 250 MHz, 10,000 megabits per second. You would use a crossover cable to connect a PC running SET directly to an IQ3. In a crossover cable, the transmitting and receiving pairs of wires are crossed. This type of direct connection between two devices eliminates the need for switch. When we want to connect a PC running SET to multiple devices on a network, we must use a switch. A switch allows for formation of a network of many devices and boosts the electrical signal to allow travel over another 328 feet of cable. Switches come in many shapes and sizes and different numbers of connections. Wiring of devices on an Ethernet network uses a star topology. You use a router to join two different networks, so a router has at least two connections, one for each separate network. The job of a router is to ensure that data packets from a device on one network segment are sent to the intended device on a different network segment. Each network interface has a unique identifier, a 48-bit number made up of 6 pairs of hexadecimal numbers called a MAC. A MAC is hardwired into each Ethernet network interface and cannot be changed. A MAC does not offer an addressing scheme. It is a unique identifier of each Ethernet device. Because each Ethernet MAC is unique, a switch can forward data to the correct device on a network segment, subnet, based on its IP address and its MAC. Each device in an IP network must have a unique IP address. This address has two parts: a network portion, commonly referred to as the network prefix, and a host number. The network prefix is also known as the network number or network ID. The address 192.168.1.8 is a standard IPv4 address in a dotted decimal format. Without more information, it isn't possible to say what the network prefix or the host number are. Nowadays, it's common to use the classless interdomain routing or CIDR notation, which in this case is 192.168.1.8/16. This is to say the network prefix is 192.168 and the host number is 1.8. The older way of expressing this, the subnet mask of this address, is 255.255.0.0. The two notations say the same thing. The term port can mean different things depending on the context. For example, we might speak of a port as the RJ45 connector socket, where you plug in the 10-base T cable, and sometimes people refer to an I/O point in a controller as a port. IQ3 controllers operate on an Ethernet network using the TCP/IP network protocols. However, the IQ systems on Ethernet also uses the User Diagram Protocol UDP, which also has ports. The Trend IQ system communicates using UDP to build the IQ network, to send messages through routers, and to transfer global Trend IC comms. A UDP port is a 16-bit number in the range 0 to 65,535. Each application in the controller is associated with a unique UDP port number, so when two devices communicate through a particular UDP port, both the transmitting and receiving devices know which application or function to use. Trend uses these common port numbers: 21 FTP for transferring files over a network, 25 SMTP for sending alarms to an email address, 80 HTTP for accessing IQ3 web pages, 2774 for sending trend alarms across a wide area network, 10,001 through 10,019 for the trend supervisor to connect to a CNC, 47808 for communication using the BACnet over IP protocol, 57612 for exchanging data between IQ controllers using Trend network comms. When you connect Trend devices on an Ethernet network and power them up, each device automatically broadcasts messages on UDP port 57612. The devices map other Trend devices on the Trend IQ system network over Ethernet. Okay, that's it for the brief refresh of your network knowledge. It's important to have all this in mind before you learn about Trend's IP tool. Complete Activity 1 in the Trend IP tool topic in the workbook. Leave this presentation open and return here when you finish the activity. Then click Next to continue. Welcome back from completing your workbook. Now, let's see what you remember. I want you to take the mouse and navigate to the IP tool. This will work pretty much like IP tool does live. If you miss a step, I'll remind you of the correct action. So, pretend that you're sitting at your PC, connected to an IQ3 controller, and SET is running. Click the menu items to launch IP tool. Good. The first step is to click the Tools menu in SET's main menu. Then you click the Trend IP tool. Now, let's review what you've learned in the workbook. Click the toolbar of the Trend IP tool window. The toolbar along the top of the window contains buttons that provide easy access to some of IP tool's functions. You use the IP tool within SET to discover Trend devices on the Ethernet segment you're connected to. An IP tool makes it simple to set up the address settings of IQ system Ethernet devices. You can use IP tool to discover all Trend IQ system Ethernet devices only on the Ethernet network segment to which the PC is connected. Click the Connect button to discover the IQ3 controllers. The Connect button in IP Tool's toolbar causes IP Tool to look for trend Ethernet devices on the local network. In this IP Tool window, identify the place where IP Tool displays the IP address of the PC running set. Then type the IP address of the PC in the text box. IP Tool displays the IP address of the PC running set in the Windows banner, also called the title bar. In this case, that address is 192.168.1.207, and the subnet mask for the PC's IP address is 255.255.255.0. When you connect to the Ethernet network, IP Tool immediately looks for trend devices on the network segment. It identifies trend devices by their MAC. The MAC of every trend device begins with 001070. In this case, IP Tool found only one Ethernet device on the local subnet, an IQ3. Click the device list in the IP Tool window. The device list displays all the trend IQ Ethernet devices on the same Ethernet network segment as the PC running IP Tool. The IP Tool cannot detect IQ3 devices on a different Ethernet network segment, and it does not show non-trend devices. IP Tool lists discovered devices here. It identifies each device by its MAC. Click the IQ3 Energy Controller in the device list to choose it. After IP Tool discovers trend devices, you can view their settings to look for duplicate addresses, settings that have not been configured, or settings that are incorrect, for example, duplicate IP addresses. Click the Editing panel of the Trend IP Tool window. The Editing panel contains the various settings that relate to the device selected in the devices list. The IP Tool talks at the MAC or Ethernet layer because this is the only surefire way to communicate with the devices on the network segment. They may be configured with IP addresses different from the network to which they're connected. For example, IQ3 controllers come from the factory with the same IP address. If automatic IP address assignment is available when the IQ3s connect to the network, then each will be assigned a unique IP address. If DHCP is not enabled, IP Tool must be able to talk with them before you configure their IP addresses to work on a network. It is unlikely that the IP addresses in the IQ3s from the factory will match the network assigned to a PC. So, IP Tool discovers Ethernet devices whose MAC begins with 001070 and communicates at the MAC layer before you configure IP address and port. If there is no DHCP server on the network, an IQ3 negotiates a link local address using a method called Automatic Private IP Addressing, APIPA, or AutoIP. A link local address is in the range 169.254.1.0/16 through 169.254.255/16 or 169.254.0.0/16. IQ3 controllers support both a static or fixed IP address and an address assigned by a DHCP server on the network, sometimes called automatic IP addressing. Click the checkbox on the window where you set up the controller to use DHCP to get its IP address. To tell the IQ3 to look for a DHCP server for its address assignment, you check the box beside Auto IP DHCP. Then you must specify a host name and use that host name to refer to the IQ3. Enabling standalone mode in an IQ3 eliminates IQ network communication, including intercontroller communications and alarms, truly separating it from other IQ3s or EINCs on the IQ system network. This makes an IQ3 invisible to other IQ3s. Click the area where you configured the controller in standalone mode. You uncheck the box beside Networked to configure an IQ3 controller for standalone operation and eliminate Trend Network communications as well as communication with all other IQ3 controllers. Click Disconnect to continue. You may need to configure IQ3 controllers that have been set up for different IP networks. So IP Tool communicates at the network and transport layers. You know enough now to do some work with IP Tool. I want you to take the mouse and complete these steps. This will work pretty much like IP Tool does live. If you miss a step, I'll remind you of the correct action. So pretend that IP Tool is running within set and that the PC is connected to an IQ3 controller. You'll connect to the network and configure the Ethernet parameters of the IQ3 by following these steps. Connect to the Ethernet network. Choose the IQ3 controller. Set Auto IP Address Assignment to On. Set the trend address for LAN 11, Node 11, and the identifier is HW System. Add a virtual CNC at Node 101, default port 10101. Send the changes to the controller and confirm that your changes were uploaded to the controller. IQ3s are set at the factory to trend LAN 20 and node address 20, so you must configure the trend address of an IQ3 when there are multiple units on the same Ethernet network segment. By the way, IQ3 binks are set to address 9 on LAN 9 at the factory. The node address must be unique among all IQ3s in the IQ system. Every virtual CNC on a trend network must have a unique member. No two devices can have the same virtual CNC address. If this happens, there is an address conflict and SET cannot communicate with these devices. Notice that IP Tool indicates its commands in the status bar. These messages tell what is happening as IP Tool sends the information to the controller. And pay attention to the hourglass icon, both beside the identifier and in the row for this controller in the device list. It may take a few moments for the information to be updated in the IQ3 and displayed here. The hourglass remains until the update is complete. Then you'll see the updated values here in the editing pane. Notice that the hourglass has been replaced by the check mark. This means that the network address information has been successfully sent to the controller. Good job. There's just one more topic about IP Tool I want you to know about. When you have multiple IQ3 controllers on separate Ethernet network segments, create a remote trend devices table in the IQ3 controller to allow trend IQ communications between all the IQ3 controllers on different network segments. Complete Activity 2 in the Trend IP Tool topic in the workbook. Leave this presentation open and return here when you finish the activity. Then click Next to continue.